Good morning, guys. This is Miss Medill, and today we're going to be talking about the real number system. You guys have actually seen this before. This is not the first time. You've seen this in sixth grade, you've seen this in seventh grade, and now you're going to see it again in eighth grade. The only real difference from last year to this year is that we have what are called irrational numbers, okay? And you can sometimes see this in squares, or they actually sometimes do circles. So let's start from the beginning. We're going to start with natural numbers. Another word for natural numbers are counting numbers. And so that basically just gave you the answer. So natural numbers are going to be numbers that you can count. Okay, numbers you can count. So when you're little, you start 1, 2, 3, 4. Any number that you can count, that is going to be a natural number. It's going to fall in the subset, in the set natural numbers. This is a set. Okay, now natural numbers are a subset of whole numbers. That means that they fit into the category whole numbers. Okay, so whole numbers are actually going to be numbers that you can count and 0. Okay, so whole numbers are going to be numbers that you can count and 0. I'm actually going to put that right here. Sorry, I'm just adjusting. Okay, and they so like I said, natural numbers are a subset of whole numbers. So whole numbers, now we're going to have all of the counting numbers, and now we're going to add 0. Now with integers, okay, the set integers, natural numbers are a subset of whole numbers, and that means that these two are a subset of integers, okay? So integers are going to be all the numbers that you can count and 0, and this time we're going to add their opposites, so those negative numbers that we get. Okay, those negative numbers. So now we have 1, 2, 3, 4 into whatever infinity, 0, and then -1, -2, -3, -4, all of those numbers. Okay, so that is the set integers. Okay, integers are going to be a subset of rational numbers. Okay, so rational numbers are going to have all the numbers you can count, 0, and their opposites. And this time we are going to add fractions. Okay, and fractions. Okay, so all of these you should be pretty familiar with. So now we're going to go into irrationals. Okay, so irrational numbers are just going to be numbers that you cannot write as fractions. Okay, you cannot write these as fractions. Okay, so let's practice. Okay, and these are going to be on their own. Okay, they're completely separate. They don't have anything in common with any of these numbers here. So let's look at 0. So 0 is actually a whole number. We talked about that. Okay, it is a whole number. So because it's in the first time you see 0, it's in a whole number. So that means that 0 is a whole number. It's also an integer. It's also rational, and it's also a real number. Okay, let's look at -5. The first time that we see negatives is going to be in integers. So that means that -5 is not only an integer, but it's also a rational number, and it's also real. Okay, so sometimes numbers fall into different sets. Okay, now 5 squared, I know that 5 squared is 25, and the first time I see 25 is in natural numbers. So that means that 5 squared, or 25, is a natural number. It's a whole number. It's also an integer. It's also rational, and it's also a real number. Okay. Then we have the decimal numbers that I wanted to get into. Now, when you have a terminating decimal, which means that's a number that stops, like 1.23, that is going to be a a rational number. This actually goes here. I'm sorry. It is a rational number, okay? Because it terminates. numbers like 2/3, which if I change it, I know that's going to be 0.666666666. Because I can guess that the next number is going to be 6, this is also going to be a rational number. Now, the problem becomes is with numbers like this. So I have 6.3578 and it says dot, 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 dot. Now, because it doesn't follow a pattern and I don't know which number is coming next, this is what I would call an irrational number. It doesn't make sense. It's kind of crazy. Okay. I don't know what's coming. Another huge one is pi. We know that we approximate pi to be 3.14, but that is not the end of that number. Pi is 3.14159 dot, 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 dot. And because I don't know what that number is exactly, what my next number is going to be, that's going to be an irrational number as well. Okay. And then the square root of 2, that's also an irrational number. It doesn't matter if I add a whole number to it, because that first number is really crazy and I don't know what's coming next. I can guess that this number is also going to be irrational. So I want you now to take the time to take these remaining ones that we have. I'll give you a second to kind of look at this page. I want you to take the remaining section of these and see if you can group them. Okay. And if you have any questions, like always, I'm here if you need me. So let me know. And I will see you guys later. Bye.